Hi, good morning. I'm just waiting for 1 more minute so that you people can connect properly and get set with your books, copies, pens, everything. Okay, so let's get started. I will be today basically discussing questions from your Newton's laws of motion from work, power, energy. And the very first question that again we are going to take is from your wave optics. So there is just one question from that. And after that, we will be moving ahead to Newton's laws of motion and then to work, power, and energy. Nitin and Som, your audios are not connected. Just try connecting to the audio, then only you will be able to hear. Okay. Chalo. So there is a screen on the question. Sorry, there is a question on the screen. I hope you all can see. Everyone can see the screen. Is question visible? Is question visible to everyone? Okay, done. So I'm giving you some 3 minutes or 3.5 minutes for this question. Read the question properly. That will take you some 1 minute, done, 1 or 1.5 minutes, and then do it. Do this question first, then we will be moving ahead with other topics. Okay, just a revision for what you have studied in wave optics. Let's do it. I'm here only. If you have any doubt, let me know. Otherwise, do solve the question. Good morning. Done hai? Are you people getting the answer? You just need to read the question carefully first. So reading the question will help you a lot. You will get to know what you have to calculate. And after question reading is done, question is actually easy if you know the concept. So in the class, I have talked about the shape of fringes. I talked about two kind of scenarios, and from there only questions have been coming since now. What are those cases? First case I told you, in the normal case, like in YDAC setup, what used to be there the case, there was a source, something S1 and then S2. So line combining these sources is this line, and a screen is this. So line connecting two sources and the screen are parallel, right? So in this case, I said you ki whatever right fringes we will be getting on the screen will be hyperbolic in shape. And if this distance is very much greater than that of distance between the sources, then these hyperbolic fringes will appear as straight lines. Then that I have discussed. And second case I discussed, if your sources are something like this, if it is S1, S2, and line combining sources is such that it is perpendicular to the screen, means light coming from these two sources are interfering at this point on the screen, such that this screen is perpendicular to the line joining these two sources. In that case, I have told you that shape of fringes will be how much? It will be circular. Then here only a slight modifications had been done in this question. That slight modification is what? Only the upper part of a screen is visible, lower part of a screen is not present. Just see in the question, lower part of the screen is not there. So like if whole screen would have been present, what you can say about the shape of fringes? It will be circular, something like this, done with center being this O point. Okay. Now, if this half portion is missing, it means we will be getting semicircular shape of fringes. Done. So what the options are? Semicircular, bright and dark band centered at point O. And what the options are? Rest. Just read through it. The reason very close to the point O will be dark, that we will see later. Straight, bright and dark band parallel to the x-axis. Straight bands we can't obtain here. Hyperbolic bright, no. Hyperbolic also we can't obtain here. So A seems like correct. Semicircular, bright and dark bands centered at point O. Over. It's not circular because half portion of the screen is missing. Again, this was a thing that you need to have in your memory actually. If you go on writing the equations, it will be just out of the domain. Done. So we just need to remember it. Again, it's asking the reason very close to the point O will be dark or bright. So it's talking about point O. So let's see at point O, if we obtain dark band or bright band. So how we will be able to calculate that? Just see at any point if you have to check if at that point we are going to obtain dark or bright band. For that, what we used to do, for that we will take light from first source, we will take light from second source, and we will see what is the path difference. Then, so if it is talking about point O, so light traveling from S1 will cover how much distance? This distance. And light coming from S2 will cover how much distance to reach O? This much distance, right? So this is your X1, this is your X2. X1 is greater than X2. And what will be the path difference? Path difference will be X1 minus X2. And if we are going to subtract this, it will be equal to distance between the sources. And what is the distance between sources given? That is your 0.6003 millimeter. So this is my path difference. Now we need to check if this path difference is integral multiple of lambda, or if this path difference is something in this sense. If it is like this, we will get maxima. If it is like this, we will get minima. Then how to now? Just it's a play of digits only, because questions already we have solved, but still we need to reach up to the answer. So you just see here carefully. Wavelength of light is 600 nanometer, and here 600.6003 something kind of is there. So can we modify it to look like wavelength plus some digit? Let's see. So if you are going to write it like this, 6033 into 10 to the power minus 7 meter, we can write it like this. Then here wavelength is in range of nanometer. So path difference also try to make it in the range of nanometer. So 600,300 into 10 to the power minus 9. Now I can write like this, right? So this is how much? 603,00300 nanometer, right? So this I can write as 600 plus 300 nanometer. Done. And here 600 is what? Wavelength. And 300 will be what? Lambda by 2. So this much is the path difference. So path difference is in form of 2n plus 1 lambda by 2, where n value is how much? If you're going to see, this n value will become 1. So definitely this point is going to be a dark fringe. It will contain dark fringe, not the bright one. So the correct answer will be B also. And C and D are incorrect, that we have already seen. Right? So this is the way we were going to. So question was not difficult at first. At first, I must say it was not difficult. We just needed to have certain thing in our head, and after that we needed to simply solve it in a proper manner so that we could reach up to the answer. Done. Chalo, theek hai. So correct answer was A and B. Now this is a question from your what Newton's laws of motion. Like, apply the things whatever you have studied it. Just apply here. I'm giving you 3 minutes. Then do it. Question is easy. It's not difficult. Read the question properly. Reading is very important, and that too properly. So give time to the reading, and after that solving will become easier. Okay. So read it carefully and do it. And in a case of any doubt, you can text me. Chalo, karo. Simple application of Newton's laws of motion, like simple use of pseudo force will come into account here. You just need to write the free body diagram of bead when you have accelerated the wire forward with certain acceleration, right? So you just need to do that. If I hint here, so system, it is looking like what a wire, a piece of wire is bent in the shape of parabola y equal to kx square. So you all are maths student, you can clearly see that this is a equation of parabola such that its diagram will look something like this, right? You all know better than me. Then in this case, so this will be the diagram for wire. This is the shape of wire, and what is happening? It has a bead of mass m on it, and bead can slide on the wire. Then initially, definitely, if we are keeping the wire here to stay at the equilibrium, it will come somewhere here and it will stay here in equilibrium. Then so initially the question is said that wire is in equilibrium, and what is its equilibrium position? Its equilibrium position is at the bottom. So this is the equilibrium position. Now what is happening? Now suppose we are keeping it inside a car. Suppose we are keeping it inside a car, and this car is moving forward with acceleration A. Then that is said in the question. Wire is given certain acceleration in the forward or backward direction, whatever direction you give. So I have given it in forward direction. It will accelerate here. So what will happen? Bead initially was at equilibrium at which position? At the center position, right? Now what will happen to the bead if it is accelerated with acceleration A? Definitely on since this bead is now kept on a wire which is accelerating. So if I am sitting on the wire and trying to see the bead, then I am sitting on what kind of frame? Am I sitting on an inertial or non-inertial frame? Definitely non-inertial frame, because this wire is accelerating. And if sitting on the wire, I try to write the equation of this speed. What I will do first, I will apply a pseudo force on it. You have studied already, if you are writing equation from the from non-inertial frame, you need to apply a pseudo force. And pseudo force is what? Mass into the acceleration of frame, and its direction used to be the opposite to the direction of acceleration. So the moment wire will start accelerating in the forward direction, for an observer sitting on the wire, this bead will experience a force in this direction, ma. So it will start climbing in this direction. Done. So finally, suppose bead is coming here and then it is getting at rest. So if it is at rest, then total forces value must be here what? 0. So one force is your pseudo force here in this direction, ma. Mg will act vertically downward always, and normal always acts perpendicular to the surface of contact. So here it is normal. Now these three forces when added together must be equal to 0 for B to be in equilibrium at this point, right? So if we can resolve, which force to resolve? First, the question is this. So you just see here, if we resolve normal along this direction, so we will get n. If this angle is theta, then this angle will be theta. So this will become n cos theta, and this will become how much? N sin theta. So n sin theta will be equal to ma, and n cos theta will be equal to mg. So if you're going to write that here, n cos theta is equal to mg, and n sin theta is equal to how much? ma. So if you're going to divide these two, what we are going to get? We are going to get cot theta equal to g by a. So tan theta will be equal to a by g. But we have to calculate distance of new equilibrium position of bead, where the bead can stay in rest with respect to wire from the y-axis. Distance of this point from the y-axis means, if I go on to draw the diagram again clearly, then question is asking key, if new equilibrium position is this, then it's asking about this distance, right? Distance of equilibrium point from the y-axis. So it's asking about the x coordinate of this point, right? So how we will do that? Tan theta equal to a by g we have got. So can we do something with the tan theta here? Can we calculate tan theta in term of x here? So what was the theta? Theta was, if you see carefully, I have taken this angle to be theta, and then normal with the vertically upward direction was making angle what? Theta, vertically opposite angle. Then this was the normal force direction. So n cos theta was equal to mg. That so theta is angle between perpendicular to the wire at this point and vertically upward direction. So theta is angle between this line and this line. If you see carefully, this line and this line can be said as ki, just see carefully now. Here the play of geometry is there. So if we are going to draw tangent at this point, then so this tangent with this x-axis will be making how much angle? Theta or not? Theta is angle between what? Vertically upward direction and perpendicular to the point P say. So this is the angle between theta. I have told you if angle between two lines is theta, then angle between their perpendiculars will also be theta. So perpendiculars means perpendicular to this line means tangent at that point. This is this. Perpendicular to this line means this line. Then so angle between this line and this line is also going to be how much? This angle is going to be how much? Theta. Then so this is nothing but the slope at point P. This is nothing but the slope at point P, 180 minus theta. Then this is nothing but slope. So tan theta can be written as slope of the point P. Then slope of this curve at point P, right? And slope we can calculate from the equation, because for this curve equation is given, equation is how much? Y is equal to ax square. So dy by dx, that is slope, that is tan theta at point P, will be equal to 2ax. So tan theta you can write as 2ax, and that is, sorry, 2kx, k is there, sorry. So 2kx equal to a by g. So x will be equal to how much? A by 2kg. So question was easy in the sense that you needed to write the FBD. Up to this, it's damn easy. Tan theta equal to A by G, you got, simple. Now you need to relate tan theta, means you just you need to think how to get the x. So tan theta we can write from the equation, because here theta is angle between normal and vertically opposite line, and this theta is nothing but the slope of point P. Done? Clear? I hope it is clear. Anyone having any doubt, let me know. You need to be clear with the geometry, right? If geometry is clear, concept is clear, this question was easy. Done? And this much we need to know. Chalo, okay. So this is again a question. I am giving you 4 minutes of your time. 4 minutes, why? Because question is seemingly long. So you need to give more time to reading. But again, if you have got the essence of question, it's easy to solve. Again, I'm telling you. So read the question carefully and try solving it. I've given you some 4 minutes. In case of any doubt, let me know. Huh? Even if it's stuck with the question somewhere, you can let me know. Sorry, I have included this question because it takes time to read, but once you have understood the question, there is not much concept to use, just simple concept we need to use. Done? That is why I have included it here. So give your time, stay patient and do it. हो रहा है? In question discussion also, I'm just including easy to medium questions. Done. So just see the question here. Put a uniform meter scale horizontally on your extended index finger with the left one at 00 and the right one at 90. So we have taken a meter scale, right? Meter scale means how much long it will be. If this is my meter scale, then this will be 100 centimeter long. Then initially my left finger is at where is at 00. Then and my right finger is at where it is at 90. So 90 centimeter and its center will be somewhere 50 centimeter. Then 50, 0. XY, in terms of XY coordinate, I'm writing. Now this is the diagram in initial case. When you attempt to move both the fingers slowly towards the center, now you're trying to move both the fingers slowly towards this direction. Then what is happening in first hand? So what is happening? Only the left finger slips. Only the left finger, that is, this is your left finger, right? So only the left finger is slipping. Just say this is the meter scale. You have kept some index finger, something like this. So initially what is happening? Only your left finger is slipping and your right finger is what? With respect to the scale, and right finger does not. It means initially what will happen? Right finger will stay at 90 and left finger will go on forward. It will slip. Done. So if you are going to write the FBD of this setup at this instant of time, suppose, then what you will do, left hand finger is just say this is a meter scale and you're holding it in your hand, in your upon your finger. So this finger will apply a normal force on the scale in upward direction, no doubt. Done. So it will apply upward force. Now let's draw those forces. Initially I'm drawing, just giving an example. So suppose it is applying N1 normal force and it will apply how much force? N2 normal force. Then this is, and its center, this scale will have some mass. A center of mass is here, and it will, and through this will act your gravitational force, that is mg. What else? Initially it is said that left hand of finger is slipping and this is not slipping. Not slipping ka matlab what? Not slipping means what? Whatever horizontal force I am applying here, whatever I am putting an effort to move the finger here, that is getting balanced by friction force at this point. That is why my right finger is not moving, right? So right finger will apply friction force, value equal to mu s into static coefficient of friction I will use, because right hand of the finger is not moving. So static friction. And here what is happening? It is moving. It means the friction acting here, my finger is moving in this direction. Friction acting in this direction will be equal to how much? Mu k n1. Then, so this will be the case. Now, this is the whole thing that you needed to draw actually at two instant for calculating XR, that I will come to later. But you just see here, this scale is in rest. It is not moving. My finger is moving along it, such that this scale is in what? Rest. Done. So all the vertical and downward forces will get balanced. So what you're going to write in first hand, N1 plus N2 equal to mg. All the horizontal forces are going to get balanced. So what you will write, mu k N1 will be equal to mu s N2 initially. Done. So this is the case. And also it's not rotating, right? So torque about this center or about any one point that you choose. But as discussed earlier, I have said you have to, if you needed to calculate the torque, either calculate torque about center of mass or calculate the torque about a point at which it has a chance to rotate, or at which, or second point you can take as the axis of rotation that I have told you before. So here in the question, to solve it, actually, we don't need to write the torque equation, but still, if you want me to write that, you just see here, this friction force is something crossing like this, and torque of friction force will be what? It will be 0 or non-zero. That I want to ask. Torque of friction force here around the center will be 0 or non-zero. Anyone? First. Dekho, these are simple things now. We need to know how to calculate torque. Done. How to find out the torque. Done. So these are very simple application of rotation that we might get in question in electrostat, in magnetism. So these basic things we should know how to calculate the torque. So here torque of friction will be what? That is why I've included this question. I don't mean to waste your time actually. I'm just trying to, whatever topics we have discussed, no questions you leave in those topics. And for that, we need to know basics of everything. That is why this. So just tell me, what is the friction torque here around center of mass? Anyone? Type karo. Batao jaldi se. Chalo, you can do. Not coming. देखो क्या करना क्या है यहाँ पे, देखो ध्यान से, टॉर्क का फॉर्मूला क्या होता है? टॉर्क का फॉर्मूला होता है आर क्रॉस एफ, यही होता है ना. Torque will be 0 in which cases? First thing is that I am calculating torque about this. So I am saying this is my axis of rotation. Then, so I am calculating torque about this. Now, friction force here acting is in this direction. Let me call it F2. And that here it is acting in this direction. Let me call it F1. So if you extend the force here, F2, if I'm going to extend, it will intersect the point at which, around which I'm going to calculate the torque. So if your force is intersecting that point, then torque will be 0. Because here R is becoming 0. R cross F. Its distance, जैसे force here, if I go on to calculate torque because of N2. So line of application of N2 is this. And my point around which I'm going to calculate torque is this. Now distance between these two is how much? This is L by 2 something. Suppose, no, this was 90 actually, according to our question. So this was this. Now what will be the torque? So torque ke liye direction we need na. So I simply, what I do, R cross F. So I start from the point around which we have to calculate. Then I just travel the distance R. So R. Now here I will rotate around N2. So N2 is in upward or downward direction? Upward. So from here I will rotate up. So my torque because of N2 will become how much? It will become 90 into N2. In which direction? In this. Done. Because of friction, it is what? 0. Because here R is what? 0. This force is intersecting this point around which we are calculating torque. So that is 0. F1 also 0. Now this is your what? N1. Now torque distance is how much? This. So R cross F. How I do R cross F? I start from here. R cross N1 की तरफ जाऊंगी. N1 is in upward direction. So this. So this is in which direction? It's initially this force was at what distance? 50. So 50 into N1 I will write in this direction. Done. So these two are opposite direction. Torque because of mg will become 0. Again, it is passing through that point only. So here also it will be, R will be 0, theta will be 0. So torque because of mg is also 0. And to make it in equilibrium, these two torque will be equal. Opposite, they are in direction, so they can be magnitude wise equal. So this was the basic thing that you needed to think here to write the net force equal to 0. So net force equated. We have equated it here. Net torque will also be 0. That I have done here. Now, let's get back to the question and solve it. So what it is saying that if after some distance, left finger stops and the right one starts slipping. Then after some distance, so let's draw the diagram in next page. So what is happening? Initially, this is the center, right? Initially, my right hand finger was at 90. My left hand finger was at 0, 0, and it was slipping. So it moved some distance, and at certain point, what happened? My left finger is here. Suppose this distance is x, and just at this position vector, my left finger stopped slipping, and my right finger started slipping. That the question is saying, right? Then the right finger, after some distance, left finger stops and right one starts slipping. Then the right finger stops at distance xr from the center of a scale, and then left one starts slipping. Done. So the question is in bit, a lot of states are there actually. So what happened? The moment it stopped, it started slipping. And then it reached somewhere here at xr distance, my right finger. Then again it stopped and it started moving. So it is asking you what will be this xr distance. Done. So how we will calculate that? So we can calculate first x, and then we can calculate easily xr. Why it is important? Because see here, I have written here n1 plus n2 equal to mg, right? This is again another equation. And if we need to calculate x ka wala thing, we need to write the torque wala thing, right? So let's do that now. Suppose what I am doing at xr, I am going to write the equilibrium. So at this point, this one I am telling at n2, and this was at this point n1. So what I will write here, n1 plus n2 will be equal to how much? Mg. Done. And what friction force will be there at XR? Just at the time just it reached XR, it stopped. Before that it was sleeping, right? And at that point of time, my left hand finger was at X and it was at rest. Done. So just before it reached XR, I'm going to write the friction wala direction. So on this left finger, static friction will act because it was at rest and this one was moving, right? So here static friction will act. What you will write here? Static friction means mu S N1 you will write, and here you will write what? Mu K N2. Then this is very important. So this thing we are going to do. Now if torque we are going to apply, then torque will be how much? N1X should be equal to N2XR. Done. So we can easily solve this equation. If these two equations, if we solve, then we can get XR. But for that, we need X also, right? We need X, right? So for X calculation, we can again write this set of equation one step behind. Means at the point when our right finger was at 90 and my left finger was moving. And at the point when left finger had just reached X and right finger had just started slipping from 90 towards center. Done. So at that point of time, you need to write once more. Then we can easily solve this question. Now, so let's write at that point. Again, I'm using the notation N1, N2 again all the time through all the cases, but they are different in magnitude actually. Variables I'm taking like that. So for that case, again, N1 plus N2 will be equal to mg. That is going to be for sure. Now at that point, only thing we need to careful about is where static friction is acting and where sliding friction is acting. Done. So at that point, my right finger was at rest at 90. So here static friction was acting. So what you will write? Mu S N2, right? That we are going to write. Done. And here what we will be writing? Mu K N1. Done. Again, it will be N1X equal to N2 into 90 because it was at 90. Now solve these two equations, you will get X. So I'm doing that for you here. What was the mu K value? Mu K value was 0.32 and mu S is 0.4 because mu K will be always less than mu S, right? So one is 0.32. If I'm going to put those values here, I'm going to do this here. So mu K is how much? 0.4 N1 equal to how much? 0.3 N2. So N1 by N2 we can write as N1 by N2. We can write as 0.32 it is. So 0.32 by 0.4 into X will be equal to 90. So if we are going to solve it, how much value we are going to get? 8 by 10. Something like that, no? So X value, am I right? N1X N2 90 I have done. So this is your 8 now, and this will be your 10. So put the values carefully actually. If you're going to put that, you will be getting certain value of X. Have I written everything correctly here? Values. Come on guys, reply. I also need motivation. Come on. So 0.4 N1 I have written now. N1. देखो मैंने गलत लिखा है ना यहाँ पे. You people are not marking it यार. This is bad. Mu K N1 was na. So mu K N1 if I'm going to write, let's come to the answer na. That will be more exciting. So mu K is how much here? 0.32 into N1. And mu S is how much? 0.4 N2. So N1 by N2. N1 by N2 is how much? 0.4 by 0.32 equal to X है यहाँ पे equal to 90. So if we are going to solve it, this 10 will go up and this is 8, this. So X will become how much? 72. So X is becoming 72. Done. So X value we have got. Now we can easily put the values here. So mu S N1. Mu S is how much? How is mu S? Mu S is your 0.4 by 0.32 will be equal to how much? N2 by N1. Done? Have I written it correctly? Just check with that here, please. So N2 by N1, X equal to X is 72, N2 by N1 is how much? This is, if I'm going to cut it, so this will become 10 by 8 into XR. So how much value you're going to get? 6. So actually we are not getting it right actually. Somewhere we have done mistake in calculation. चलो ठीक है कोई नहीं. So the logic was this actually. You can recheck it with the calculation. Everything I have written here correctly only. Somewhere we might be here also we have done the mistake I guess. So N2 okay. तुम लोग सच में blind हो. Are you people really blind? Not noticing anything? Yeah, this was 1990 na. So this was 1990 na. So this distance will become how much? This whole was 100 na, 1990. So this whole is 50 na. So this will become how much? 40 na. So here it will be 40, right? Yes, Nitin. यार बोल दिया करो ना एक बार. I'm also here stuck. 40 होगा ना यहाँ पे. So this is your 40. So how much you are going to get? This will be your 32. So this is your 32. Again, here I have done mistake. No. So 32, 10 by 8. XR will be equal to how much? 8 into 2, 6. 8 into 3, 25.6 centimeter XR. This is your answer. Done. So here we wrote 90 now. That distance from here will be 40 only, no, not 90. Clear hai? Chalo. So question was not difficult actually. You needed to draw the diagram carefully, and carefully you needed to write mu k and mu s. Where you will be writing mu k, where you will be writing mu s. That only careful point was there. Otherwise, question was crackable. Chalo, theek hai. Take deep breath for 1 minute, everyone. चलो किसी को कोई तकलीफ है, कोई दर्द है, कुछ बुरा फील हो रहा है और ज्यादा अच्छा लग रहा है तो भी बताओ. All positivity and negativity needs to be communicated, right? That you should not keep inside yourself. चलो कुछ प्रॉब्लम है तो बताओ. Anything you can tell me. After all, I am a teacher. Being a teacher is a huge responsibility, you know. Chalo, it seems you people are ready for the question. No one talking. So I'm giving you again 3 minutes. Do it fast. Chalo, you people are very brave, not taking break and doing everything. Question is easy again. Take 3 minutes. Think carefully. Do it. Just write the FBD of this block. Okay. For rest condition, you will be calculating net force equal to 0. Done. Net force along which direction? How to take the direction actually? चलो ठीक है, पहले तुम लोग कर लो, then I will discuss. Okay. Do it first. अच्छा, कोई तो चाय पी रहा है। सही यार, मुझे भी चाहिए। After class, I will be making tea. If you need, I can send you in so many cups, just online tea. Yes, 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 yes. So you people getting something, 1, 2 options. This is your what? Multiple choice question answers. It will have actually more than one can be correct. Done. So just try to check. आज तुम लोग थोड़े लो लग रहे हो, परेशान हो क्या? ऋषभ, यस, वेरी गुड। परेशान नहीं होना यार, जो भी है अच्छा है, जो होगा अच्छा होगा। दिस इज ओनली इन आवर हैंड। हाँ, तो जिंदगी का मजे लो, जिंदगी को मजे मत लेने। डन। चलो ठीक है, चलो डन। लेट मी शो यू क्वेश्चन is very easy actually. You may be tired, it may be the case. A small block of mass 0.1 kg, done, this is 0.1 kg on a fixed inclined plane PQ, which make an angle theta with the horizontal. Done, it's making angle theta with the horizontal. A horizontal force of 1 Newton acts on the block. It is shown here. So for block to remain stationary, what should be the cases? And where the frictional forces will act in which cases? Then that's the question. So very first thing is, just try to think in which direction it may slide. So just in any mechanic question, if you have to resolve the forces, before resolving forces, just try to see in which two direction you have to resolve the force. Done. And for फाइंडिंग आउट दैट व्हाट यू नीड टू सी इज, आपको ये देखना है कि वो ब्लॉक को मूव करने का टेंडेंसी किधर है. सो दिस ब्लॉक कैन मूव, जैसे इफ अ पर्सन इज स्टैंडिंग हियर, he can move or she can move along earth. Then so one direction will be this, so another direction will be perpendicular to it. Similarly here, this block can slide down the inclined plane. So one line you are going to take as, one axis you are going to take as this. Suppose this is x-axis and another axis will be perpendicular to it. So this. So along these two lines, you have to break the forces. Now let's see what are the forces acting. So here, mg will act downward. Done. Clear it? And what? Let's first resolve these two forces. This angle is how much? Theta. Done. This is theta. So this will be theta. So here 1 into cos theta, and here 1 into sin theta. Again, break the mg. Mg is not along these two lines. Done. So let's break mg. So mg along this line will be how much? Mg sin theta. You all are aware of such things, right? And mg along this will be how much? Mg cos theta. So perpendicular to the plane in perpendicularly downward to the plane, how much forces is acting? Mg cos theta plus sin theta. And along the plane in which it has tendency to move, what the force is? Downward direction mg sin theta, and in the upward direction it is how much? 1 into cos theta. Done. So m value is how much? 0.1, and the g value is how much? 10. So mg cos theta, if I'm mg sin theta, if I'm going to calculate, if I'm going to put the value of m and g, it will be equal to how much? Sin theta. Done. So the block, if these two forces are equal, then no friction will act. क्योंकि friction कब लगता है? When there is a net external force acting. And if no external force is acting along the line of motion, along the line in which it has tendency to move, if no external force is acting, then friction will not act. So if this cos theta and sin theta are equal, if upward force and downward force is equal, external force is zero along the line of motion, probable line of motion, in that case, no friction will act. So what I will write here? Cos theta is equal to sin theta. You will be writing like this, right? And this is only possible if what? If theta is equal to how much? Cos theta equal to sin theta. Tan theta became here equal to 1. So theta equal to how much? 45 degree. So if the angle is 45 degree, what will happen here? Yes. So if the angle is 45 degree, what will happen? No friction will act. The block will remain stationary. Sorry. Now, what will be the case if theta is not 45? If theta is not 45, then there will be net external force acting on it. Done. In that case, sin theta will not be equal to cos theta if theta is not 45. Now, let's see if theta is less than 45. What will be the case then? So if theta is less than 45, in that case, we already know that cos ka curve seems something like this, sine ka curve seems something like this. So what happens? Initially, if theta is equal to, yes, correct. So initially what will happen as theta will increase from 0 to 45 degree. From 0 to 45 degree, cos will increase, cos will decrease. And what will happen with sine? Sine will increase. Done. So for theta less than 45 degree, will cos be greater or sine will be greater? Which one will be greater? जैसे एग्जाम्पल ही ले लो, अगर कुछ भी कंफ्यूजन हो ना तो एग्जाम्पल ले लो, 30 डिग्री का एग्जाम्पल ले लो. So cos 30 degree will be how much? Cos 30 degree is how much? √3/2. And sine 30 is how much? 1/2. So cos 30 is greater, no? So cos is greater. It means upward force will be greater than downward force. And if upward force is greater, it means upward force is greater than downward here. It means net force on this block will act up the plane. So friction will act what? Downward. So if theta is less than 45 degree, friction force acts on the block towards Q. No. Net force is along Q. So friction will act towards P. This is P here. Done. So this is wrong. Now what? If theta is greater than 45, case will be just opposite. So friction will act towards Q. So just see which one is the correct C. So A and C are correct and B and D are wrong. Okay, done. So this was your question. Now again, this is from your work power energy. Just conservation of energy you need to do here. I am giving you 3 minutes or 4 minutes. चलो मैं देती हूँ. But you need to simply read the question carefully. Question is solved after that. So take time to read the question. उसके बाद कुछ नहीं करना है. Just understand the question and then do it. चलो करो. कुछ डाउट हो तो यू कैन लेट मी नो. हाँ, in mechanics, visualization is very important. To be real is very important. You just need to see कि कैसे कैसे move करेगा. Just that's the trick here. चलो ठीक है, मैं समझाती हूँ. You just need to be careful. Again, a block B is attached to two unstressed springs, S1 and S2. So S1 and S2 are what? Unstressed with a spring constant K. S1 spring constant is K, and for S2 spring constant is how much? 4K. Now the other ends are attached to two supports, M1 and M2. Done. ब्लॉक बी भी मूव हुआ है. यस, ब्लॉक बी भी मूव हुआ है. बिल्कुल क्वेश्चन में दिया हुआ है ना, देखो पढ़ते. द अदर एंड आर अटैच्ड टू टू सपोर्ट्स M1 एंड M2. M1 और M2 से दोनों एंड अटैच्ड है. अदर टू एंड्स एंड अदर 1-2 ends are attached with the block B. Now the spring and supports have negligible mass. This is very important observation here. Its mass is 0 and also its mass is 0. Spring has mass 0. Now there is no friction. Again, friction is not there. The block B is displaced towards the wall 1. Now block B is getting displaced towards the wall 1. What will happen? Just try to think of over this. So this is block B now, and this is attached with S1, and there is a mass here. Again, this is something like this. Done. And it is also attached with a spring here, and there is a mass again here, and there is a wall. Now what will happen? If I'm displacing it like towards this, so this spring will start getting compressed. So it will start getting compressed. What will happen? In that process, this block is not going to move, because on this, there is no that kind of forces acting now, because this is applying a force. This is moving towards this. So this is compressing the spring. Done. So it will remain here. Now, can you imagine now? If B is moving towards the spring, what is going to happen? It is just in the favorable, in the favor of this block to stay here. If we will extend this block in this direction, or we will move this block in this direction, then the spring will get extended and this block will start moving here. But in this case, first case, what is happening? Block is moving towards this sense. So block M1 का कोई tension नहीं है. It will remain there. This spring is getting compressed. And what about this here now? So this spring will start getting elongated. It will start getting elongated, and so it will pull this mass. Done. So what will happen now? It will elongate in this direction, and this by same distance this mass will get traveled towards this direction. Done. So more it will get elongated, more it will move here. Done. So what is going to happen? Yes, S2 में कोई compression, S2 में extension होगा ना initially. जब when you are pushing mass B or block B towards M1, what will happen? S1 will get compressed, it will get compressed and it will get extended. But this extension will get balanced by the motion of mass M2 towards S2. Done? Clear hai? So we gave it certain displacement, and because of that work done, what is happening? This spring is getting compressed, this spring is getting elongated, but this mass is moving towards it and balancing its elongation. Clear hai? So that is happening. Now, where the energy is getting stored, we need to look at that. So S1 energy is getting stored in S1. So if we have displaced it by distance x, that is given here, no, by distance x. Yes. So how much will be the compression in a spring S1? It will be equal to half kx square. I am telling you in S2 there is nothing, no extension, no compression, so no energy. Again, this mass M2 is moving by. So it will have kinetic energy, but here mass is 0. So our question is damn simple. Mass is 0 means no kinetic energy it will have. So only energy getting stored is in form of potential energy in the spring S1 in first case. And that energy is equal to how much? Half kx square. Done. Now what will happen in the second case? Second case means this block got displaced towards M1. So it got compressed by certain distance x. Now what is happening? Now after maximum compression, this block B will, if I'm going to draw the diagram here, and if the spring is maximum compressed here, block B, this compressed spring will apply force on this block B in this direction. Done. So it will apply force in this direction. Done. And at a point, it will attain its natural length. So all this kinetic energy stored in the spring will get converted into kinetic energy of this block. Done. And after that, this block will start compressing. This block is moving in this direction. It will start compressing this spring S2. So if it compresses S2, M2 will move something here. So it's compressing. And at a certain point, its B velocity will become 0. It means all its energy it has given to a spring S2 in the form of potential energy, then its velocity will become equal to what? अच्छा, S2 में compression क्यों होगा ये समझ में नहीं है. Okay, my dear, you need to visualize it. Okay, so just see the cases that is happening. Just focus your brain. What is the happening here? What the question is? The block B is displaced towards wall 1 by a small distance x and released. So displaced by a small distance x, so it got compressed by x, that you understood. And during that compression, there was no extension here. It's simply this block moved and its compression and elongation was 0. So it got compressed maximum by x. Now it won't stay compressed. Now spring will apply force. So this spring, compressed spring, will apply force on block B in this direction. So block B will start moving in this direction. Done. And it will start moving in this direction. The more it will move in this direction, its compression will decrease. And at a point, its compression will become 0. X will become 0. And this block B is moving in this direction. Again, when it is moving in this direction, it will try to compress the spring S2. But at the same time, M2 will also move in this direction. Done. So initially, compression will get balanced by motion of M2. Done. So no net compression. Again, this is moving. One at a point, M2 will touch here. Again, this block is still moving. Done. So now it will compress it. Once M2 has touched the wall now, and B is moving towards it, so spring S2 has no other option than to get compressed. So a spring S2 will get compressed. How much? Until this B velocity will become equal to 0. And at that point, all its kinetic energy, that is equal to half kx square will get converted into potential energy of a spring S2. And during that motion, S1 will have no compression, no elongation, same as the first logic and reasoning. Done. So what is going to happen in the second case? All potential energy is in the form of here what? So sorry, all this energy got converted into potential energy of a spring S2. S2 has got compressed by how much distance? Y. So that energy is going to be half K का value क्या है? 4K है into Y square. So these two energy must be equal. Now you can compare X and Y. So this was your thing. Clear है सबको? Everyone understood? किसी को doubt है? Okay. किसी को डाउट है, यू कैन रेज योर हैंड, यू कैन स्पीक, यू कैन ड्रॉप इन द चैट बॉक्स, और समझ गए हो तो प्लीज वो भी बता दिया करो, अच्छा फील होगा मुझे। नो डाउट ना, चलो ठीक है, ये क्वेश्चन हम बाद में करते हैं। आई वांटेड टू मेक यू अंडरस्टैंड समथिंग एंड दैट इज हियर, ठीक है। चलो इसको लेते हैं एक बार। यहाँ पे क्या है, एक्चुअली दिस इज अ टॉपिक, एक्सटेंडेड टॉपिक है, इससे बहुत बार क्वेश्चंस आता है एंड वेरी famous topic also at the same time. Here in the question, if I'm going to just read it, I want to explain it actually. So there is a particle of unit mass and is moving along the x-axis under the influence of a force and its total energy is conserved. Again, total energy conserved है। इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि there is no non-conservative force around. Then, if there is a friction, non-conservative force, total energy won't be conserved. It will die out with time. Then, but here it is conserved, no non-conservative forces. Now, 4 possible forms of potential energy of particle are given. Potential energy is given. Done? Clear है? What we have to calculate? First, देखो options में क्या क्या दिया हुआ है. Force acting on the particle is 0, 0 kind of. We have to check. So potential energy से force कैसे निकालते हैं? Very first thing. So force equal to, तुम सबको पता होगा, conservative force. Again, this must be conservative. Minus du by dx, है ना? This used to be conservative force formula from potential energy, and for getting points at which force is 0, we can equate it to 0. That is easy, huh? So we can calculate key at which point force is going to be 0. Now in the options, there are also points like the particle experiences an attractive force towards this. मतलब हमें ये बताना है कि in what duration particle will experience attractive force. It may ask in what duration particle will experience repulsive force. So what's the logic of attractive and repulsive force actually? So you must have a study, like in physics, this is widespread, ki if there is attraction between two bodies, their energy will be what? If attraction is happening, suppose you are taking two charges, plus Q and minus Q, they are moving towards each other because of attractive force. So attractive force is acting. Now the potential energy will work, decrease or increase? It will decrease, right? क्योंकि potential energy का formula आपने पढ़ा होगा, minus k q q by r. R is decreasing, so overall magnitude is increasing, negative sign, so it is decreasing. So if attractive force is acting, then our potential energy will what? Decrease in that duration, right? So if it is asking the particle experience attractive or repulsive force, so you will check during that duration if potential energy is increasing or decreasing. If it is increasing, force acting is repulsive. If it is decreasing, force acting is what? Attractive. Done है? अब देखो यहाँ पे एक और क्वेश्चन है, particle with total this much energy can oscillate about the point this. Again, if we have to check for the probability of oscillation, how oscillation will happen? Done. So for that you need to check कि you must have studied how to check for the equilibrium from potential energy equation. If potential energy equation is given, how you can calculate the equilibrium points? So equilibrium points means force acting will be 0. So what you will be doing? You will be calculating du by dx equal to 0. So you will be getting, suppose x1, x2, x3. 3 points suppose you are getting. At these 3 points, force is 0. So this is an equilibrium point. Again, some points will be a point of a stable equilibrium, and some points will be a point of unstable equilibrium. Then, so oscillation will only happen if from the equilibrium. Oscillation का मतलब क्या होता है कि if your ball is at equilibrium position and if you are displacing it, it has tendency to come back to the position. Done. And it will be only possible if that equilibrium point is stable. Done. And how to check for the stable points? A stable points means, again, there is a second strategy. You must have studied that. Just calculate the second differentiation. So second differentiation is this. And if it is greater than 0, second differentiation का कुछ equation आएगा. And in that equation, you will be putting the value of x1. Done. And if that is greater than 0, it will be stable equilibrium point. Done. And if it is a stable equilibrium point, then around that oscillation is possible. चलो मैं एक क्वेश्चन करके दिखाती हूँ, ठीक है? That will be more helpful for you guys. So, what's the case? First question क्या है? U naught by 2 it is. U equal to how much? U naught by 2, and here it is 1 plus x by a ka square side. Sorry, 1 minus. Done. So here it is minus, not plus. Again, calculation please ध्यान से देखना. जहां पे गलत हो, please let me know, huh? Please. So again, I'm going to first calculate the point at which forces will be 0 because that is asked in the option. So I'm going to do minus du by dx equal to 0 because that will be equal to force. Again, if I'm going to differentiate it, what value I'm going to get? तो चलो सबसे पहले ना मैं इसको ब्रेक ही कर देती हूँ. So it will be u naught by 2, 1 plus x4 by a4 minus 2x square by a square. This is, we have to differentiate this. Again, if you're going to differentiate it, I'm not going to write all the equations kind of. Direct differentiation I'm going to do. So here, what value we will be getting? We will be getting 4x cube by a4 minus 4x by a square equal to 0. Done. Now let's take the common and all whatever is required. So if you're going to do that, 4x, take that as common. And what will remain? 4x by a square, let's take as the common. So what will remain here? X square by a square minus 1 equal to 0. Now what can be the probable values of x? So 4x by a square can be equal to 0. So x equal to 0. Roots I'm just calculating. And x will be equal to plus minus a. So options if you're going to get, if you're going to look at, so force acting on the particle is 0 at x equal to a, correct? Force acting on the particle is 0 at x equal to 0, correct? Force acting on the particle is 0 at x equal to minus a, correct? So all these PQR are correct. Now let's check S. The particle experiences an attractive force towards x equal to 0 in the region this. Again, how we will check that? तो देखो हम सबसे पहले एक काम करना है, एक लाइन ड्रॉ कर लो. So what are the equilibrium points? Let's denote that first. So what are those? Let's take it as 0, 0. So one point is minus a0 and another point is what? U का तो 0 हो जाएगा ना. U का differentiation तुम बोल रहे हो. जैसे U naught का पूछ रहे हो ना. U naught by 2 is a constant ना. So it will stay outside. और 0 equate कर रहे हैं तो constant इधर जाएगा तो 0 हो जाएगा ना. Are you getting me? What's your name? Your name is just written in the short form. I can't read it. How can I? But U का क्या होगा differentiation में? What you are asking? Yes, वो constant ही है. U naught by 2 is constant. U equal to U naught by 2 है ना? Okay, if I'm going to write it now, what will be the differentiation? Minus du by dx now. So minus d by dx you will be writing here. And here you will be writing u naught by 2, 1 minus x by a का square. That you are going to do now. हाँ, as it is copy हो जाता है. तो copy किया नहीं किया मैंने क्योंकि वो all ultimately 0 हो जाता है यार. अच्छा ठीक है चलो. u naught by 2 यहाँ लिखती हूँ. u naught by 2. I told you ना मैं रफ कर रही हूँ. तो u0/2 यहाँ से इधर जाएगा तो 0 ही होगा ना, यू आर करेक्ट, एज इट इज कॉपी होगा ऐसा, बट ये तो इधर जाएगा तो 0 हो जाएगा ना, इसलिए मैंने नहीं लिखा उसको, ठीक है, डन, ओके, थैंक यू। सो व्हाट कैन वी सी हियर, इक्विलिब्रियम पॉइंट्स मुझे 3 मिले थे ना, डन, तो इक्विलिब्रियम पॉइंट मुझे 3 मिले, -a0, 0, 0 एंड a0। मुझे पूछा है कि इस जब देखो क्वेश्चन को ध्यान से पढ़ लो एक बार, ऑप्शन क्या है, पार्टिकल एक्सपीरियंसेस एन अट्रैक्टिव फोर्स टुवर्ड्स x इक्वल टू 0, टुवर्ड्स x इक्वल टू 0 मींस as we are moving towards 0, then it is saying it is experiencing what kind of force, attractive force. For that we will have to see, we will have to randomly take any point here. Suppose at -a0 potential energy is how much, just put the value of x equal to -a. So if you are going to put x equal to -a in the potential energy equation, it will become how much, 1, 1 minus 1, 0. So here potential energy is how much, 0. So here potential energy is 0. Now if it is increasing in this direction, then potential energy is increasing, then we will say ki force acting is repulsive force. So let's check the value of potential energy for one more value of x. So x का value मैं क्या ले लूं, suppose a/2 लेती हूँ या -a/2, इधर -a/2 होगा ना, so -a/2 if I am going to put here, -1/2 का square 1/4 होगा, 1 minus 1/4 will be equal to how much, 1 minus 1/4. So this is going to be how much, 3/4 का square. So here the potential energy value is what, sorry, it is what, increasing or decreasing, potential energy is what, it is increasing now. The particle experiences an attractive force towards x equal to 0 in the region mod x less than 1. mod x less than 1 की बात कर रहा है यार, तो 0 ले नहीं सकते, a ले नहीं सकते, ठीक है, सो मेरा फर्स्ट चेकिंग ही गलत है। ओके, यू पीपल आर गेटिंग कंफ्यूज, चलो मैं नेक्स्ट पेज लेती हूँ। u का वैल्यू क्या दिया हुआ है, u0/2, 1 minus x/a का स्क्वायर, मुझसे क्वेश्चन ये पूछा है ना कि ये 0 है और ये -a है, ये +a, डन। सो यहाँ से जब इधर मूव कर रहे हैं और इधर से इधर मूव कर रहे हैं, तो मेरा फोर्स जो लग रहा है वो अट्रैक्टिव है या रिपल्सिव। सो वी नीड टू चेक, we need to take 2 points between -a and 0, 2 points, ठीक है, क्योंकि x को लेस देन mod a लिया है, इक्वल टू साइन नहीं लिया है, डन। सो वी नीड टू टेक 2 points in between -a and 0, डन। कोई भी रैंडमली 2 points ले लो एंड चेक करो कि एट these 2 points potential energy value is what. So this is potential energy का इक्वेशन। चलो मैं 2 पॉइंट लेती हूँ, एक मैं ले लेती हूँ -a/2 और दूसरा ले लेती हूँ -a/√2। चलो दोनों पे ही निकाल कर चेक कर लेते हैं। सो इफ यू आर गोइंग टू चेक इट, व्हाट विल बी द वैल्यू, u0/2, 1 minus x का वैल्यू -a/2, सो -a/2 if I am going to put, this will become 1/4, है ना। Just keep eye on the calculation that I am doing, please. So this will become equal to how much, 9/16, 9/16 into u0/2. So one value we have calculated. Second value चलो check करते हैं। So -a/√2 आप put कर दो, u0/2, 1 minus a/√2. So that will become 1/2 का square. So how much value we are going to get, u0/2 into 1/4. Yes, this is 1/4. So what is happening at -a/2? At -a/2, potential energy value is more, and at -a/√2, potential energy value is less. It is less now. 9/16 if you are going to calculate, it will be something 0.5 से greater होगा ये, done, and it will be your what, 0.2 something, done. So as we are moving towards this direction, what is happening, our potential energy is decreasing, done. So if potential energy is decreasing, it means force is what, attractive, done. So that is my correct डन. सो क्वेश्चन क्या होगा, ये भी मेरा क्या हो जाएगा, करेक्ट हो जाएगा. इस तरह से चेक करना था. ठीक है. नाउ फाइनल क्वेश्चन इज पार्टिकल विथ टोटल एनर्जी u naught by 4 can oscillate about the point x equal to minus a. So what calculation we have done? We have got equilibrium points minus a 0, 0, 0, a 0. Now try to check it out of these 3 points, which one is the case of a stable equilibrium. Done. Can you do that? Chalo, theek hai. So how you will be doing that? That you can check that equilibrium point now, and chalo, theek hai. You will be doing that thing actually. Again, I can tell you in the next class, but there are more more sections here, B, C, D. For all, you will be checking all these 4 options at least. Fifth one, I will deal in the next class actually. So you need to check with that. I have given you the answers here. All the answers are present. Okay. So that is your kind of a homework. You have to check with all the options. Done. 3 things, 4 things I have already discussed. Fifth one I will discuss later. Chalo, theek hai. So we have some 3 or 4 minutes left. मैंने बहुत लेक्चर दे दिया, इसलिए मैं सोच रही हूँ कि लेट्स डू वन क्वेश्चन. हाँ, पीडीएफ तो मैं अपलोड कर दूंगी, बिल्कुल करूंगी. नेक्स्ट क्लास का भी किया था मैंने. ठीक है. आप ये क्वेश्चन करो. दिस क्वेश्चन इज वेरी इजी एक्चुअली. टेक सम 3 मिनट. मैंने बहुत बोल लिया, तुम लोगों को दिमाग लगाने की जरूरत है. डू इट नाउ. आई विल बी अपलोडिंग पीडीएफ, डोंट वरी. विद अ प्रॉपर एक्सप्लेनेशन ऑफ फिफ्थ वन. ठीक है, मैं वो भी डाल दूंगी. You can do it in 1 or 1.5 minutes. If it get cracked, you just need to look at things carefully. Waiting for your answers. Huh? Force is given now. Yes. Particle is being taken from A0 to 0A. Trajectory is what? Circular. Circular path of radius A. And that path or that circular path has at its center at origin in the XY plane. So little bit of maths, little bit of physics. Both combined together, correct answer. डन है? नहीं हुआ? होना चाहिए था बट क्वेश्चन क्या है? पहले तो सर्कुलर ट्रांजैक्टरी बना लो. ऐसा है. चलो एक सेकंड रुक जाऊं. अच्छा, रुक गई मैं. जैसा बोलो. उस वक्त है जो नहीं रुकता. सब just imagine करो, we can say a statue to time. How much convenient it will be, huh? But we can't. चलो अब मुझे तो बोलना पड़ेगा ना. ठीक है, मैं बोल ही लेती हूँ थोड़ा और. सो यहाँ पे क्या है, what is given? You are taking that object, that particle is taken from point A0. A0 will be here. Done. From A0 to where? 0, A. This is done. Along a circular path of radius A. Radius क्या है इसका? A है. So सबसे पहले तो इस ट्रेजेक्टरी का इक्वेशन लिख लेते हैं. What will be the equation of circle here? X square plus y square equal to A square. Done. That we can write here, right? So देखो force value is what? Force given is x by x square plus y square 3 by 2. Again, x square plus y square can be written as a square. A square 3 by 2 will be equal to a cube. So x by a cube is the force, and here y by a cube is the force. Done. So force value we have got in the simplest form. Now my body is moving from here to here along this trajectory. So if for any displacement I take small displacement dl, this dl displacement will be sum of what? Something in x direction and something in y direction, I cap plus j cap. Done. And what will be the work done? Work done will be f dot dl. Done. So just simply do that. X by aq I cap plus y by aq j cap को डॉट करोगे किससे? dx I cap plus dy j cap. And if you're going to take the dot product of these two, x by aq I cap है ना, and this is your I cap. अच्छा, f को कैसे लिखा? f written is how much here? F is this na. In x direction, force acting is x by x square plus y square 3 by 2. And x square plus y square is equal to how much? A square na. Circle ka equation I have written. So x square plus y square is a square. So in this place I am writing a square. So a square ka power 3 by 2. Square square will get cancelled and that will remain a cube. Got it? चलो बता दो मुझे. Okay. Done. So here what you will be doing, x by aq dx plus and this will vary from, x will vary from where? Yes, Tripti, correct. So x will vary from where to where? X is varying from, if you are moving from here to here, x initially is a and x finally is how much? X finally is your 0. So here a to 0. And y will vary from where to where? It will vary from y initially is 0 and it will go to a. Now you need to calculate this. Then from the symmetry you can see it will come as 0. ठीक है? Chalo, you will try it. Answer is here. You can try it again. I will be uploading the notes just 20 or 30 minutes later. Okay, bye-bye. Take care. Stay positive. Keep on working and don't take a stress. Thank you, Tripti. And please take care of your health. ठीक है? अच्छे से रहो, अच्छे से खाओ, अच्छे से क्वेश्चन प्रैक्टिस करो without taking any tension. Doubt हो, contact me. In physics, I am available there for you people. कभी भी कुछ भी प्रॉब्लम हो, you can let me know. हाँ, ठीक है? चलो. Thank you so much, everyone. Bye-bye. Tata. Take care. Bye, Som. Bye-bye.